Okay, so for the warm-up, we've heard these words before. If something's parallel, those things never cross. Think about parallel lines, they would never intersect. What does it mean to be perpendicular? Well, those things do intersect. Those lines intersect and cross, and they form right angles. Here's a picture of your plane. It's like that sheet of paper. Has a length and a width, but no thickness. Kind of looks like a rhombus when we sketch it out. Okay, so another key visualization technique when dealing with 3D shapes is determining what shape will occur when we cut the shape in various places with the plane. The shape that appears is called a cross-section. So this is just a two-dimensional shape formed by slicing a three-dimensional solid with a plane. Okay, so we'll cut the shapes in two different ways. We'll either have it be parallel to the base, or we'll have it vertically through the highest point of the figure and perpendicular to the base. Okay, so if this is our triangular prism, if the cross section was coming in parallel to the base, we'd end up with a congruent triangle. Be the same shape as the base. If the cross section was perpendicular to the bases, then we can see that we'd have a rectangle. So make sure that you're sketching in those shapes on your paper, sketching a triangle, sketching the rectangle. That'll help you in your notes later. Okay, if we have a square pyramid, the base is a square. When we take our cross-section parallel to the base, we end up with a smaller rectangle. When we go perpendicular to the base, we end up with a triangle. So sketching this rectangle, sketching the triangle in your notes. Alright, if we start with a cylinder, the bases are circles, so when we cut it parallel to the bases, it's still a congruent circle. Same shape as the base. If it's perpendicular, your cross-section is just a rectangle. Sketching the circle, sketching the rectangle. If we look at a cone, okay, if we took a cross-section parallel to the base, it would be a smaller circle, since the base was a circle. And if our cross-section is perpendicular, then it will be a triangle. So last idea we need to cover involving 3D shapes is determining the length or width of irregular shapes. So here's a 3D box with some parts coming out of it. So we want to find the missing value for each variable here. Okay, so if we look at x, x is a vertical component. Here's another vertical component, and our biggest vertical component. So when we look at this, this part here is really like x, this part here is 2. So x plus 2 has to equal that whole length of 4. So x is just 2 units. Okay, when we look at y, y is going kind of horizontally. Here's another horizontal piece. Here's the whole horizontal piece. So if we look at the 4, this little part here was y, the rest of it's 3. So we can say the y plus 3 equals that whole length of 4. So y would just be 1. Alright, here's our new figure. We're trying to figure out the length of x. It's horizontal here. So is the 4. Together they make up this whole 6. So x plus 4 equals 6. X is really 2. Okay, now we're looking for y. Y is going vertical. Y is up and down. So is this 2. So is this 2. Together all of those pieces form the 7. So y is really 3. All right, now we're looking for y. It's vertical, so is this 2, so is this 2, so is this 8. So y plus 2 gives us 8. So y is really 4. Then we can take a look at x. X is the total for all of these horizontal parts. So we have 3, if we add 7, and this 2, that equals that whole length. So x is really 12. Alright, here's kind of more arrows to show you the directions that they are. If we look at y, it's this whole length. It's made up of the 5, and the 2, and the 1.5. If we look at x, it's horizontal here, so is the 8, so is the 2. Together that makes up the whole 14. Okay, it might not be a bad idea to use 2 different color pens, 2 different kind of color highlighters, like I'm working with here on the board, just to help you visualize things better. Alright, and we have all of these horizontal components. We have x plus x plus x. That's making up this whole length of 12, or we could have said 3x equals 12. When we divide by 3, x is 4. Okay, looking at our vertical pieces, we've got y plus 2y. That equals that whole length of 10. So y would equal 10/4, or we can reduce that fraction, divide both the top and bottom by 2. So you could say 5/2, or if you like decimals, 2.5. And here's our last one. Okay, if we look at x, with the 17 and the 13, that would give us this total length here, the 45. So x would be 15. And the y value is going up and down here, so it's the 18. And that would equal the whole 45. If you watch this whole video and listen to it, put a star by your name, date, and hour. I'll be looking for the star.